So hello and welcome to the Coralogix webinar. Today we're going to be talking about a really interesting topic. It's something that most engineers that I meet bump into on a regular basis. It's a really important DevOps challenge, and it covers three of probably the most commonly used operational tools and just general software tools that I see at the moment, which is Kafka, Elastic, and Kubernetes. I'll give a very brief introduction to myself. So hello there, I'm Chris. I am a senior cloud engineer. I've worked at a bunch of different companies. Right now I'm working at a very large UK-based retailer called Sainsbury's. My major focus has always been on observability, resilience, how to make engineers enjoy coming to work, but also mean that they're not solving the same problems over and over again, building that great engineering platform. Oded, how about a little bit about yourself?
Hi, Chris. So good day, everybody. My name is Oded. I'm leading the platform team at Coralogix, where my team and I are mostly responsible for our environment behavior, from Kubernetes to the infra that can be, in our case, Kafka Elastic, and the way that it's all being monitored. Thank you.
Brilliant. Thank you very much, Oded. So this is where we're going to go, okay, guys? So we're going to cover a lot of ground in this webinar. There's a great deal of information to pack in, and we're going to try and grow our knowledge, okay? So this is the final picture. We're going to talk about everything from spinning up Kubernetes clusters, guiding design principles, observability, high availability, close to using Prometheus, responding to event-driven data, and how to use that as the really bedrock of an autoscaling and upscaling strategy. We're going to talk about instance types, instant classes, cluster autoscalers, absolutely everything, frankly. We're going to talk about Kafka, Elastic, and running those at scale, and some of the brilliant experience that Oded has collected over the years. So hopefully you can bring that back to your architectures and really improve what you've got already. So there's no reason to mess around, so let's get straight into it. So guiding principles. So these are some key capabilities that you need to have in place to make sure that you are really building quality, excellent software that engineers can use and your organization can rely on. So Oded, how about you give us a brief explanation of what high availability and observability are?
Okay, so in our case, observability is basically our ability to get decision based on any event-driven behavior that our system observe. It can be monitoring metrics coming from Prometheus, Coralogix, or any other logging or monitoring product. It can be business decisions that are coming from the business. All are gathered and set up to one centralized place, which basically allows us to get a reactive or proactive decision based on the event of the system. In the case of high availability, and Coralogix is a company that believes in providing the highest high availability and stability to our customers. We basically want to make sure that our system is stable, is high available, which means that our services fulfill the SLA that we as a company expect them to fulfill.
For some people watching, they'll hear observability a lot, and they'll hear sort of observability and monitoring. So what's the difference between observability and monitoring?
So in the past, people use monitoring. When it comes to observability, it basically means that we have a lot sources of data, of events that are coming in. And based on those events or on those KPIs, I need to get a decision. This decision is coupled with my business. My look at my system is a business-oriented look. And in order to achieve this observability, in this case, I'm getting a lot of data which provide me the full picture. And I'm setting up KPIs based on those data. And so instead of looking at the world as 0, 1, I'm looking at it as an unlimited indicators that allows me to get the SLA or the behavior that I expect from my system.
Brilliant, thank you very much. I think the strapline I hear an awful lot about the two is kind of monitoring is having a set of preset questions and being able to ask them, but observability is being able to just go in and ask anything you want, whenever you want. There's nothing fixed in place. How do you feel about that definition?
So I agree with the definition, but it all depends on the events or the data that is getting into the system. In the case of monitoring, you have a predefined question or predefined answers because you only have a specific set of data that you made it up front. So the the answers are for the questions that you already know the answer for. In the case of observability, I allow you to ask any question because they have all the data.
So we've covered high availability, we've covered observability. I think they're brilliant working definitions. So to be clear on what these capabilities mean, with high availability, it's, you can lose instances, things can break, but the whole system remains. Data isn't lost. There is no lasting impact. And with observability, it's that key ability to see and ask any questions you want, and to be able to do that whenever you like without having to prepare things all up front. So let's step forward. So what I'm really interested in is what that observability actually looks like. One of the phrases that I hear a fair bit is this by default idea. So it's not enough that you have this observability capability, but you can't quite, some of your systems have it and some of your systems don't. What you want is a system that can survive, that has it across the board by default. And so the best possible option there for us is to bake it into the platform itself. So if a new node comes up, Prometheus scrapes those metrics. If a new pod comes up, Prometheus automatically sees those metrics. I think that's a really key thing to bear in mind. That observability should span your entire system, not just minor little subsections of it. So we've got an example, I think, of one of the dashboards. So Odin, I think this keeps track of your Kafka cluster. Could you talk us through this a little bit, please?
Sure. So the metrics that we gather or the dashboard that we build basically should gives us 3 levels of observability in our system. On the eye level, we want to see the entire system, how it behaves. If I see something which affects globally on our entire system, I would like to see it first, changing in the number of replicas, changing in the number of brokers, failure of a specific broker. The other part, and again, this dashboard is pretty huge, and you cannot see the entire dashboard here, but if you feel the need that you need the dashboard for Kafka, Elastic, etc., just ping me and I will share it with you. So the other part is basically getting into the Kafka or the Elastic internally, which means I want to be able to see lag behavior. I want to see the request queue size. I want to see response queue size. I want to see how the message behaves, the rate, the topics I'm working on, the number of commits that I have in the cluster. And the third metrics that we achieve or we are looking at in our company is the behavioral metrics, or mostly KPIs, which basically give us how the resource usage and the logical usage is connected to the business, how it affects on my customers, what partition affects on which customers, how is the SLA affected by changes in Kafka, etc., etc. So we basically gather all this information in one dashboard, and based on any group of metrics, doing some kind of a reactive or proactive action. And we can elaborate on that if needed.
We've got a question. Is the Elastic pod the same as the Elastic node?
Yeah. So what our design is basically that on each node we're running one pod for Elastic, and for each node we're running one pod of Kafka, which means that the pod and the node are one-to-one coupled. We on that extent we add a lot of the daemon sets that allows us to inspect the behavior of this node and pod, which means that we add things like node exporter, Kafka exporter, Elasticsearch exporter, node problem detector, and another things like node termination enter, etc. And their use in this case is to manage the behavior of those nodes and pods running on the same instance.
Brilliant, thank you. And there's another question here. Are you using daemon sets for that? But I'm not sure what that refers to.
So our Kafka and our Elasticsearch are running as a stateful set using EBS, but we're using a group of daemon sets, as I mentioned earlier, to improve our observability and event-driven behavior, to extract metrics and dashboards and event logs and information to a centralized system, and later on do our analytics on that.
Brilliant, thank you. Okay, so I think we've got another dashboard here. So this looks like Elasticsearch.
Yeah, so taking like Kafka previously, so we have also an Elasticsearch dashboard that we're building it the same structure, which means that our eye-level look is how the cluster behave. Is it green? Is it red? Our hot servers and warm servers, which is how our Elasticsearch architecture is designed, how they behave, number of shards, etc. Things like how the indices are behaving, how the thread pools are behaving, etc., etc. And going further, we have everything that is related to the business. What queries do my cluster experience? What the type of the queries that were done? Which company did the most queries? This, again, gives us a lot of information on how to act upon those changes.
I've noticed that at the top of both of those dashboards, they're quite sort of simplistic measurements, and then they move down into more complex things. Is that an intentional choice?
Yeah, so our dashboards are used by the entire company, even if they are managed by a specific team. The entire company is using it to observe, from our CEO, CTO, to any developer in the company. So when we build the dashboard, we build it to give an overlook on the system and going drill down to whatever needed based on your specific expertise.
Brilliant, thank you. Okay, so let's push on. So obviously all this data comes from somewhere. So could you talk a little bit about what's on screen here?
Yes. So Coralogix basically monitor using two major tools. One is Prometheus, like most people that use Kubernetes, and the other is we are dog fooding ourselves using our system, which means that we basically collect everything, every log that exists on the system, and based on those logs, we use our system to get a more proactive or reactive action, depends on the use case. And this example that you can see is from a tool that called an event exporter, that his role is basically fetching the Kubernetes API messages and send it to our system. So then we can take things like how much time it takes us to deploy Elasticsearch to the cluster, and based on that decide how it affects or disaffects our SLA. We can take this information and based on it identify patterns that happens in the system and use our product to identify anomalies and other stuff. And it all is done by finding the right tools that will send the right data or the event-driven data and get decision on a centralized system like Prometheus, again, Coralogix, or any other system in this field.
Brilliant. So we've got a couple of questions coming through quickly. So first is, how do you share your storage across instances for high availability?
So we're talking on which storage? The Elasticsearch storage, the Kafka storage, or the services storage?
Let's start with Elasticsearch, and then we can...
Okay, so in the case of Elasticsearch, again, we're using stateful set, and each node in the cluster is using its own EBS. And by using its own EBS, it basically holds the entire information that this node is running. And we're using, of course, a replication to the cluster in order to replicate this data between nodes. So for Kafka, we're using an EBS with ST1. We're not using an i3 or something like that. And because we are trying to achieve the stability as much as possible. For Elastic, we separate it for hot services, which are more of ingest-oriented or CPU affected, and those as also an EBS disk, which are SSD, which again shared by a replication. And we have warm services that are considered less critical, and they're also all EBS with an SSD.
But you actually answered the next question as well, so good work. So I will mark that one. Cool. Okay, so let's, without further ado, let's push forward. So scaling things is obviously a kind of scary part of running production services, or scary if you don't do it right, I suppose. So one of the things when we were having a conversation before this webinar, that you mentioned that you upscale Kafka and Elastic, you autoscale everything else. Why that distinction? Why upscale only Kafka and Elastic?
Okay, so in our case, again, and it's not always true to any company or any design that companies choose, we look or use Kafka and Elastic with a high load and with the purpose of keeping the system as stable as possible, provide our customers the ability to make sure that their data will always exist and will not be lost, hopefully. And when we are talking about Kafka and Elastic, because our system is so critical, we are looking for an upscaling approach, which is mostly true when we go to big data and cloud solutions. And it means that in our case, when we change that requires scaling, it will be a scale up. And we were just about to talk about what scale up means in the case of Kafka and Elastic. But in the case of the other parts in our system, we can live with scale up and scale down because the behavior change based on the customer behavior. So going back to upscaling Kafka and Elastic, we basically observe the behavior of Kafka and Elastic. In the first layer, we observe the changes of the resource, which is basically includes hard limits, like I have a specific limitation in the size of the disk I can have to the number of CPU I'm using. I have a specific limitation in the amount of memory that each broker can handle. I have a specific limitation in the number of partitions that each broker can run, etc., etc. And we observe those metrics and decide upon it if we need to vertical or horizontal scale the system. And then it comes to the point that we have changes in the behavior, which are more dynamic changes. If we look at Kafka, we might have a change in the request queue size. We might have a change in the response queue size. We might have changes in the rate that is coming in, and we might have changes in the batch size based on our customers. And those are decisions that upon a KPI that we define, we again upscale the cluster. And then come the business decisions. This customer requires a special cluster. This a customer affects other customers. So we break or upscale the cluster differently. And when we talk about upscale, there are two ways to upscale a cluster, or three ways. One is vertical scale. I need to increase the disk. I need to increase memory. I need to increase the CPU. This can be done till some kind of a limitation. And we have the horizontal scale, which means that I can add more instances to this cluster and more pods to this cluster. And we have an horizontal scale, which means creating a new cluster, which when observing a business requirement might, and again, a business requirement can come from the technological limitation that we have, requires us to create a new cluster. So doing an horizontal scale of a different cluster to different customers, for example. And this is true for Kafka and Elastic. But once this is done, and once we did the upscaling, and the upscaling not only includes the ability to scale the cluster, but it includes to move the customers to the right cluster. It includes the ability to reassign partition, both for Elastic and both for Kafka, and make sure that it's balanced through the entire cluster. Once this is done, we need the ability to auto-scale our services. And when it comes to our services, we're using a product that's called k8s. And this product is a Kubernetes event-driven autoscaler, which his role in life is to basically observe changes in Kafka, changes in Elastic, changes in Redis, changes in Kubernetes, changes in Prometheus, changes in specific metrics, etc. And based on those, make the decision on scaling up or down the instances. So from the infrastructure perspective, we are always going upfront. We are always scaling up. We're always increasing our infrastructure because our baseline assumption is that the business grows. But from the services perspective, we can change the behavior of the services based on the behavior of the system as a whole. If the traffic goes up, we will autoscale up. If the traffic goes down, we will decrease the number of pods, etc. This allows us to basically provide an high availability to all the aspects of our system and save costs.
Brilliant. I mean, a stack of questions just came through while you were covering that. So one question, are you running multi-cloud / multi-region deployments, or is it just AWS?
So we are running on AWS, but we are running on a multi-availability zone and multi-region setup. We have a plan to move to a multi-cloud, but it will be in the near future. For now, we are using AWS to the extent.
With your Kubernetes cluster, is that a homegrown Kubernetes instance, or is it EKS? Or?
Okay, so we are using an homegrown Kubernetes, and there are two reasons for that. The first one is basically that when we started with Kubernetes, AWS didn't provide EKS at all. It was just starting. It was a pre-product or a beta product. It didn't run in Europe and Ireland. They only have a program that runs on the US. So when we started Kubernetes, we started it because there wasn't any managed solution on AWS. Having said that, we got to a point that we cannot use a managed solution. We are changing the kubelet behavior on our cluster. We are changing the master behavior on our cluster. We are using logic that is not opinionated the way AWS expects it to be. So for us, EKS is not the right solution. But for companies that are looking for stability without the ability to optimize and need security, EKS is really a nice solution.
Very nice. How do you calculate scale for Elasticsearch and Kafka? What metrics do you monitor that provides you with this information? I.e., how do you know how big Elasticsearch is?
So it depends. If we talk for a second about Kafka, so for Kafka, we have a rate that depends on the type of the request. And based on that, we calculate the rate on the cluster. We know how to calculate rate for specific topics based on the customer traffic. We calculate bulk size, and all those metrics we basically collect using the JMX exporter, which is used to expose the entire metrics that exist in Kafka. For those of you who need the dashboard using for Kafka, which is pretty much generic, and the setup for that, feel free to ping me and I will share it with you. We have a bunch of metrics. Again, most of them are being collected from the JMX exporter, and we have the KPI we define to our organization, to our customer behavior, to the number that we agree upon. Consume the resource that we expect it to be consumed, and based on arriving to the point of maximize those KPIs,
I actually think while we're waiting, I'm in a luxurious position to be able to answer one of the questions. So how is autoscaling handled, and is it some static configuration of k8s or by applying changes programmatically to some events? The most common mechanism for autoscaling a Kubernetes cluster is obviously the cluster autoscaler service. So this works across cloud, most commonly, my experience with from AWS. With AWS, the cluster autoscaler will essentially alter the values on an auto-scaling group. So you have a desired amount, a max amount, and a minimum amount, and the cluster autoscaler pod will increase and decrease that desired amount based on whether there's room in the pod. So it takes information from the scheduler in Kubernetes, which is responsible for allocating pods to certain nodes. So I think that's a stack of questions we need to get through. Brilliant, actually, loads of really good ones here. So first of all, what is the high availability for the Prometheus configuration you're using? So how do you keep Prometheus going, and how do you handle outages in Prometheus?
We have our Kubernetes. Our Prometheus design is it? You hear me? Because or it's okay. You hear me? Okay. Okay. So our Prometheus design is based on Prometheus and Thanos today. The way we handle Prometheus is basically we have a concept that was set up by our chief architect in the company, which called the CX product, which means that a group of services are being basically monitored using two Prometheuses. And again, you can think of it as like a manual sharding, but it's more than that, because it's a manual sharding based on the business purpose of the services it monitored. So we have a Prometheus that is basically, or two Prometheuses in this case, that is set up for services, and it's true for any group of services that are running in the system. And all of those Prometheus are working with Thanos, and they have a front end or a query, a querier that sits remotely and basically connect to all of them and allow us from one centralized place using Grafana and the Thanos front end to be able to query those entire Prometheus's setup. So we achieve high availability by using two Prometheus or three Prometheus, depends on the design, for a group of services. And of course, we have again an observability and monitoring that monitors the Prometheus and knows how to set up limitation, like the number of samples that the Prometheus allows us to read, etc. And it is done as some kind of a manual or business sharding based on the purpose. And again, when I say manual sharding, it's not that I'm doing it manually, it's that by design Prometheus doesn't do sharding by itself. So we set up a group of Prometheuses and basically treat them as an exporter from the point of view of our system. So basically a scraper that collects all the information for groups services and send it to the next service in the line.
Thank you. So there's a start. We're not going to be able to get through all these questions, a whole bunch. So sorry about that in advance. How do you? Okay, so do you use the Kafka Lag Exporter? Maybe log? I'm not sure.
So we're using, again, JMX exporter for Kafka and the Minion exporter. A Minion is a project that we found out recently using the help of our CTO. And this project basically gives a lot of information, a really interesting information that is not observable through the JMX exporter metrics, like the commits and the lag and other information, and it's fit to the use of newer versions of Kafka as opposed to Kafka exporter that is suggested by Kafka and by Confluent. I didn't mention it, but we're using Kafka 2.5, and we used to use the Kafka exporter, and it caused us a lot of issues because those driver was really old. We are now using Dominion, and we are really satisfied with this behavior. And again, if you need help with that, feel free to ping me.
Brilliant, thank you. So I'll just do one more and then we'll have to move on just for the sake of time. So what advantages have you found running Kafka on Kubernetes?
Okay, so basically the entire management, the entire deployment and the entire Kubernetes behavior fits to Kafka behavior. Again, when it comes to scaling, by design, Kafka is meant to upscale and not downscale. And Kubernetes fit this pattern in this case because it allows us to move Kafka brokers from one instance to another. It allows us to replace an instance without failing the cluster or worrying about it. It allows us to control deployments more easily, and it allows us to shard information between availability zones really easily. And again, some of it is features that are based in Kafka itself, like the rec, but some of them we gain most of them by using Kubernetes to ease up the deployment process and the management process of those brokers.
Just a very, very quick one. Could you please repeat the name of the exporter you mentioned, Oded?
Minion. I can share it with you if you want in the chat.
Yes, perfect. That'd be good.
Okay.
Okay, we're going to have to press on, but there is a question section at the end. So your questions aren't gone, so we'll definitely do our best to pick them up at the end. Okay, cool. So the next topic, selecting the correct EC2 instances for Elastic and Kafka. So Odin, I suppose the obvious question, why is selecting the correct EC2 instance so important for tools like Elastic and Kafka?
So for Kafka and Elastic, mostly when companies, and again, companies in our size and in behavior, are looking at Kafka and Elastic as central and a super important ingredient in their setup. And it means in the end that we, as a company, probably most of the companies that are using Elastic and Kafka are looking for stability. They are looking for a system that is scalable but stable. And then it comes to the question of whether I will use, again, managed services or I will use my own Kafka and Elastic. And it comes to the question of one, stability, which managed services give most of the time, and two, the limitation that whether I can control or not. And for us, Kafka and Elastic are again, centralized ingredient in our solution, which means by the end of the day that we want to control their behavior. And when it comes to controlling their behavior, we need to be sure that we choose the right EC2, we choose the right EBS, and we choose the right behavior of those instances in order to achieve high availability and stability in the end. So in our case, for Elastic and Kafka, we chose to use R5 series, which is more memory optimized. In the case of Kafka, the answer is pretty clear because Kafka is not CPU bound, but it's more of a memory bound. And for Kafka, we're using EBS of type ST1, and we're using it because we get to the point that we consider stability is the most important thing. And in the case of AWS EC2 and EBS specifically as a high durability and high availability, which give us basically by using their functionality. So we chose EC2 instances that are EBS dependent and not instances like i3 that are more ephemeral disks that we can lose due to a failure of an instance. And when it comes to, again, Kafka and Elasticsearch, we want to make sure that our system is resilient. We want to make sure that even if it fails, the failure can be solved pretty quickly or as quick as possible. And there Kubernetes comes in because it see that there is a degradation in the behavior of the instance, and based on this degradation, it can decide to replace the instance and using the EBS, all the information is being kept. And it's the same design is true to Kafka, and the same design in our case is true to Elastic. In the case of Elastic, we separate between instances that are more CPU bound and memory bound, and there we use R5 to extra large, and instances that are more memory bound without the CPU bound, and then we use R5 extra large. And there is an important part of EBS using SSD instead of EBS using SD1, because the way Elasticsearch works. And there are companies that probably will choose using i3, but in our case, again, the critical path, the ability to make sure that the cluster is up as much as possible, the time that it reduces the fact that the most latest state is being kept in EBS are all worth the price of not using an i3 IOPS IOPS disks.
So there's one question that just came through then is how do you handle / detect EBS volume failure in Elastic and Kafka?
So we have a CloudWatch exporter, and we have the event exporter, which both I mentioned the event exporter in the beginning. And it's a really interesting project that takes all the information from Kubernetes, all the API, all the event collected by Kubernetes. And one drawback of Kubernetes is that it only keeps it for around 45 minutes. So by sending this data to a centralized system like Coralogix and using product like CloudWatch exporter to Prometheus, we basically can take those two metrics and get the full picture of changes that happen in AWS and changes that happen in Kubernetes cluster, and understand what happened, what we need to do, and how we should behave in that case.
Brilliant. And so there's a question here that came through a little while ago. It's a good one, actually. So Kafka containers and nodes in Kubernetes constantly die for a variety of reasons, exceeding allocated resources, routine maintenance, security patching. Do you see any issues caused by this when managing a Kafka cluster in Kubernetes? And if so, how do you tackle it?
So the way even by design, Kafka is not is considered a data source or infrastructure a product, but by design it's really fit to Kubernetes. Because failing Kafka is not the end of the world. It means that if I lose one or even two based on my replica, one or two nodes, I am able to get back to action pretty quick. Because the way Kafka works, it basically uses the leader and it writes and reads for it, and that way it basically keeps its durability. So losing one broker or two broker, as long as I'm willing and able to handle the load for fetching replica, and again, this is a configuration that can be controlled as part of Kafka, and as long as I'm willing to stand some kind of lag when the replica being fetched from the leader, I'm pretty good to go. And I'm not saying it's easy. By the end of the day, those needs to be calculated based on your design and on the traffic and the load of the system, and understand that if one or two Kafka, and again, this is something that you need to be ready for, are going to fail, this is going to affect the rate of reading from disk and the rate of traffic that run between the nodes. But as long as you calculate it in your KPIs, it's something that is really durable and something that are really easy to manage.
Thank you. And one of the things that I've done, I've certainly done it in the past, definitely with development environments, is running everything on Spot instances. So someone's come through with a question now. Do you use Spot instances for Elastic at all? For Elasticsearch on DevShared, we're using it from time to time, and again, it depends if your development environment
is shared between a lot of developers, or is it used only by you? And if your team is able and want to take care of Elastic in case of a failure, or you have a centralized team that is responsible for that behavior. And all of those are basically a business decision that can affect the reasoning of using the spot, because sometimes the price of the spot doesn't worth the time that you need to invest in it. But from the other perspective, using spots basically make you ready to any change that is going to happen in the cloud. And in production, we're using spot instances to things like client and ingest client that are used by Elasticsearch. The other parts, which are more data oriented, we keep as our eyes, because we want, again, to keep the stability of our customers. It doesn't mean that if it fails, our data is lost or we have an issue, but it means that we want it, most of the time it won't fail.
Agreed.
And it's, by the way, it's super different from the way we are looking on services. From the services point of view, we want them to fail as much as possible and to be durable and available as much as possible, which means that we put them on spot. We use a lot of techniques to keep them up and running as much as possible, which means we're using things like mixed pool instances. That means that we have different types of pools of instances on AWS. So if I'm trying to run instances, they can run on C5 to extra large, but they can also run on C5D, on C5N, on M5 and on R5, as long as the number of CPU is kept as static, as the base number, or at least as the base number. And we're using things like spot allocation strategies of the lowest price with instance pools. So we do some works behind the scene to make sure this will be highly available while using an infrastructure that can fail at any time, and it basically improve our cost but improves our services.
I think it's that idea of injecting chaos, right? You intentionally create some chaos in your system. So
it's by design, yeah. It's by design.
Yeah. It's not a bug; it's a feature.
Yeah.
Cool. So there's a bunch of questions. We'll move on. There's a section for questions at the end. So what we can do towards the end is we'll just rattle through a bunch of them. So we've just got one more piece actually. So Oded, so the way I kind of did this, so a few years ago when you started working on Elasticsearch and Kafka, if you could go back to then and tell your previous self some really, really important tips, facts, just things that you wish you knew back then, are there any things that come to mind?
So in Kafka and Elastic, and I'm sure that most people that are in this webinar are aware of, you can do a lot of optimization, but I want to get to the side of the Kubernetes, which is, I can say, pretty new to the new the design, to the new world. As I see it, when you get to the point that you need to optimize Kubernetes if you want to use it to things like Kafka or to things like Elastic. And two parameters that we find really attractive in this scope or domain are CPU manager policy, which we set it to static for Kubernetes, for Kafka and for Elastic, which basically means that for the type of those applications, if it's Scala or Java applications, we give the Docker or the pod that is running to use the entire core instead of using horizontal behavior that basically Kubernetes is all about, the CPU horizontal behavior. And we are using something that's called eviction art, which basically give us the ability to be able to fail the pod or evict the pod before the instance fails by itself. In the past, when we didn't set those value like eviction art, we consider issues where the instance was failing and the EBS was not disconnecting and the pod was basically hang up. And we understand that in order to improve it, we need to do it from the server side or from the pod side using resources and limits. but we also need to set it up from the instance side. And those parameters needs to be considered when you work with Kubernetes, because Kubernetes looks as great platform that basically makes you forget about the most important system operation, like optimizing the instance that you are running on and optimize the service that is running on Kubernetes.
Brilliant. Well, thank you very much for that. So really, I think the message that I got from that personally is that while obviously Elasticsearch and Kafka have their own nuances and their own language and their own configuration, really mastering that underlying platform, mastering Kubernetes in that respect will pay benefits to both Elasticsearch and Kafka, and really that's the most important thing. Is that correct?
Yeah, I believe so.
Brilliant. Okay, well, I think that's another slide. So we have an absolute litany of questions. So if it's okay with you, Oded, we'll go through a few of these.
Sure, no problem.
Apologies in advance if we overrun you guys. I'll try and get through as many of these as possible because there's some really, really great questions in here. So do you use any non-AWS third-party tooling?
What do you mean by non-AWS third parties for what? We're using...
Yeah, I'm not completely sure. I think perhaps this question might have been answered. It's a little bit of an older question. It might have been answered throughout the webinar. So there's a series of open source tools that are engaged with Coralogix. And
okay, so if I understand correctly, we're using other tools from the cloud perspective. We're using AWS. We're not using currently GCP or Azure. For other product, we do use third parties, but this is part of our design, our on-call behavior, our authentication, our security, etc., etc. And if I understand correctly, if it meant to the cloud, so no, we're using currently only AWS.
Excellent, thank you. How does the Autoscaler handle changes to the Elastic instance, so rebalancing indices, increasing shards, and Kafka, adding new topics? So when you're upscaling, how do you automate these Elasticsearch and Kafka specific processes?
Okay, so in the case of Kafka and Elastic, it's basically the same. Autoscaling is only the way we add more instances and pods based on the relevant metrics. But other than that, we have a bunch of controllers that their role in life is to do the reassignment, is to set up the template, it's to change the number of partitions, is to move customers to the right cluster, is to balance the cluster as a whole. HPA today doesn't give it as part of Kubernetes. It only knows how to increase the number of nodes and pods. So as I started in the beginning of the session, all the observability that we gain from it is helping us auto-scale those services, which means scaling the nodes and the pods, but we also use as proactive actions, which basically trigger our own controllers that responsible to make the cluster balance. If it's Kafka or Elastic.
Great, thank you. And how do you actually, how do you manage a Kafka rebalance? So in terms of an operator such as Strimzy?
So we're not using Strimzy. I can say that we read about it and we thought about using it, and we thought about using cruise control, and we had a lot of thought about using operator for this purpose. And up until now, we didn't see any operator that help us to fulfill our scenarios. We saw a lot of operators. Each one of them has a small part of our needs. But our need, it depends on the way we manage our business, whether a developer is the one that is responsible to set up the topics, and then CRUD is a great solution. Their streams really help you to achieve it. But reassigning is different, rolling upgrade is different. So today we are facing two options: either to build something ourselves, and we are doing it using a smaller part of controllers, like controllers that are not gathered to an operator, or taking an existing operator and add to it the mechanism that we already built.
Thank you. So there's one here. Do you use the new data streams feature of Elastic? And if yes, how does it perform comparing with the classic indices in Elastic and Kubernetes?
Sorry, I missed you. Sorry, what?
Are you using the new data streams feature in Elastic?
No, we most of the data streams that we're using are developed on our side. We're using the latest Elasticsearch, but mostly we set up the feature to fit our business needs.
Right, cool. And I think the previous question about non-AWS tooling, there's been a clarification. So I think the question was more AWS alternatives, for example, Terraform. So rather than using cloud formation, using Terraform.
Yeah, so we are using Terraform, we're using charts, and we're using a language that's called DAL that helps us to basically take the entire system and standardize it, use it to become a one API that is used by our entire system. And this all is gathered with the code that is being written in Go, in Python, and all is being gathered together to solve a complete solution or a complete suite that should help us handle the cluster. Terraform is used only to building the underlying infrastructure. Upon that, we are using again DAL and some programming languages to set up the Kubernetes cluster, and upon it, we're using sometimes DAL, sometimes Helm charts to deploy the services based on the scenario, based on the need.
Do you make use of an operator in your Kubernetes cluster, or is it just deployed via a replica set?
Sorry, I missed it.
So for your, I'm presuming this means for your Kafka and Elasticsearch instances, do you have an operator that helps generate new instances, or do you have things deployed via a deployment in a replica set?
So in the case of Kubernetes and Elasticsearch, the same is that we build something that basically do exactly that. So the controller or the autoscaler adds the instance, and based on that behavior, we create a stateful set code that is built upon all the configuration that we set up to this Elasticsearch or Kafka in this case.
Brilliant. Do you use a single Elasticsearch cluster for all customers, or do you provision separate clusters per customer, or is it a hybrid of the two?
So it's an hybrid of the two. We have customers that are running on their own cluster. We have customers that are running in a shared cluster. We have around 12 clusters that are being used for all of our customers, and it depends on the size and the behavior of each customer and each setup. But we are not managing a single one, shared one for everybody. We are managing multiple clusters in our setup.
Cool. How do you manage Kubernetes version upgrades?
Oh, so this is really interesting question. Kubernetes, and again, we are event-driven, and we are working on this method for any setup that we have in the system. So upon rolling upgrade, we basically have a controller that runs over the changes in metrics, and based on that, get the decision of whether to roll down the instance and wait for the new instance to come up and make sure that the service is up and running. And it's true for all the upgrades and changes that we do in the cluster. They are all event-driven based on Coralogix. They are all event-driven based on Prometheus. We see an event, and based on this event, we decide what to do. A good example is working with Kafka. When we want to do a rolling upgrade to Kubernetes, we need to make sure that once I'm rolling Kafka, I'm rolling one by one. I need to make sure that there isn't any lag on any of our services. I need to make sure that a change in Kafka didn't affect the behavior of the customer are experiencing, and all is being gathered using metrics, and based on metrics, we are getting the decision, and we decide when and how to terminate a broker and moving a pod to run on this broker. And again, as I mentioned earlier, our system is resilient, which means that we can lose one or two brokers and even three, and everything will continue to function. And rolling upgrade is a great example for that.
Brilliant, thank you. I mean, the patching stuff in Kubernetes is like the question, right? It's always a thing. We haven't got a lot of time. We're actually overrunning now. I'll try and get through a few of these questions. If a customer really wants a dedicated cluster, can they just, presumably, that can be organized as well?
Sorry?
So you mentioned that customers sometimes are on the shared cluster, sometimes they get their own cluster. But presumably, if a customer really needs a dedicated cluster, that's something that can...
Yeah, so again, part of our controller that we build to Elastic and Kubernetes his goal is to identify the behavior of the customer, and it can be manual change or automatically change. And based on the customer behavior, we move it from one cluster to another. And we're using a functionality that exists on Elastic that allows us to basically read from all of our cluster, but write to the right cluster. So moving a customer doesn't affect the old data, basically continue from the place that is stopped. So moving a customer to its own cluster won't cause an issue until the data will be deleted and everything will move to the new cluster.
Excellent, thank you. We mentioned before a plugin that you used. So what plugin would you, sorry, I'll ask the question properly. Can you write down what plugin you use to evict the pod from an unhealthy server? So, and what metrics would you use to indicate that a server is unhealthy?
What plugin do I use to evict?
Yeah, so I know, so I suppose question number one, are there any third-party or open source tools that you have in Kubernetes that will detect when a server is unhealthy and evict a pod, or do you just rely on Kubernetes automatically?
Okay, yeah, I understand, sorry. So basically we have a denote problem detector which identifies changes in the operating system. It can be an OOM, it can be a kernel issue, etc. We're using node termination handler to identify maintenance that is done by AWS, and upon this maintenance, the node termination handler basically check the AWS metadata and identify the autoscaler that this pod need to be evicted and moved to another node. We are using a Coralogix exporter for similar reasons, like making sure that there aren't any degradation in the EBS or EC2 behavior. We are using the event exporter tool to identify issues with like logs that are coming from the event of the cluster and identify issues with pending instances, EBS that are got stuck, etc. And all those basically provide us all the information that we need to either evict pod and move it to a new cluster or increase the number of nodes and the HPA based on changes that happening on real time.
Brilliant. I think this might be the last question we can answer. Quite sharply. So, could you give an example of 1 to 2 of the main Kubernetes customizations that were done that aren't supported by EKS?
That are not being supported by EKS?
Correct, yeah.
So this is what I mentioned in the tips in the end. Any change that you want to have to kubelet, for example, is not supported by AWS because by design, AWS doesn't allow you to change kubelet because you can cause a lot of damage for them and for you. We are using 2 parameters that we saw that are really affecting our cluster behavior. And those are configured also on AWS as a default, which doesn't fit to our needs. One of them is the CPU manager policy. A CPU manager policy in our case is static, which allows us, based on the definition of resources on Kubernetes, resources like CPU and memory, and defining the right CPU and the right request and limit, allows us to basically give our services and services like Kafka and Elasticsearch the ability to use all of the CPU for themselves instead of sharing it with other services running in the cluster. And another thing is which I mentioned is the eviction arg, which defines upon how much memory that is left on the instance. The instance will start evicting pods and it's true for a node file system also, image file system, etc. We are using those parameters to optimize and to improve the behavior of our Kubernetes cluster. And this is something that it's not supported by AWS to manually change or automatically change.